Hello everyone, myself Dr. Girin Saikia, a faculty member of Department of Statistics, Durham College. So here we are going to discuss about some basic points on probability, and this one is from BSc first semester under FY UGP program. Uh, these are some important terms generally used in probability. Uh, the first one is a random experiment. So with an example, suppose you are going to introduce that one. What actually random experiment implies for? Suppose you are going to toss a coin. So in an unbiased coin, there will be two faces, either head or tail. So these are the possibilities. So exactly we don't know whether there will be a head or tail in our first try. That is, the exact prediction in any tossing is impossible. So these type of experiments are generally known as random experiment. So on the other hand, so you can say that an experiment whose all impossible outcomes are known and which can be repeated under identical conditions, but the exact prediction of the outcomes in any particular cases, that means trial, is impossible. So next, trial or events. So the performance of an experiment, that means a random experiment, is itself a trial, and the results obtained after the trial is known as events. That means in a coin tossing problem. So tossing a coin itself is a trial, and this head and tail, these are the events. So similarly, if we consider mutually exclusive events, so those events are said to be mutually exclusive if the happening of any one of them prevents the happening of the all others. Correct? So in a throwing a die problem, so there will be six different phases. So up to six. So if we throw this die, so there will be either one or two or up to six. So this one actually prevents the others. That means when we occur the one in our first throw, that means this one actually prevents the all other events. So that type of events are generally known as mutually exclusive events. Or you can say in a coin tossing problem. So there are two mutually exclusive events, head and tail. Next, we are going for exhaustive events. So exhaustive events is nothing but the total number of possible events. That means total number of outcomes in an experiment are known as uh, exhaustive events. So in coin tossing problem, there are two exhaustive events, head and tail, and in a throwing a die problem, so there are six different exhaustive number of cases. Okay. So in this slide, also there are some important terms basically used in probability. So next one is equally likely events. So the events are said to be equally likely if after taking all the relevant evidences, there is no reason to accept or expect one in preference to the other. So there will be no preferences in any events, that means in any trials. So test type of events are generally known as equally likely events. If you consider uh, in a coin tossing problem, so when there may be either head or tail, so that there will be no preferences whether that one will be tail or head. So this type of events are known as equally likely. Or you can consider in a throwing a die problem. So there are six different phases. up to 6. So we cannot actually give more importance to any one of them. So that is why these 1 to 6 points all are equally likely. Similarly, next, if we're going to these independent events, so suppose a die is thrown twice. Okay, so when we are throwing a die twice, then the occurrence of any point in the second throw is not affected by the points obtained in the first throw. So these type of uh, events are generally known as independent events. Okay, or you can say if two or more events can occur without affecting the occurrence of each other, then they are said to be independent. So last one, that means uh, okay. So favorable cases. So favorable cases are those cases which are related to the happening of events. Uh, if we consider in a throwing a die problem, and we are interested in getting suppose multiple of 3. So there are 3 uh, in a die problem. So there will be 1 to up to 6. So we are interested in multiple of 3 to getting the results multiple of 3. Here the points 3 and 6 are favorable cases for our cases. That is, these 2 points are related to the happening of that event. So these type of events are or cases are known as favorable cases. So by considering all the terms, and we can compile this sample space. That means the set of all possible events in a trial. That means the set of all possible events in an experiment is called sample space. So the sample space is generally denoted by S, and as written as, suppose if we are considered in a coin tossing problem, so there will be 2 possible sets. Okay. So next we are going for the different definition of probability. So this definition of probability can be classified in 3 different categories: classical probability, and statistical or empirical probability, and last one is axiomatic probability. So in our today's class, we will discuss only classical probability, and the later one we will also discuss the remaining two. In classical probability, suppose there are n mutually exclusive events. If we consider, suppose there are n mutually exclusive events, those are also exhaustive and equally likely events. And suppose you consider there are m numbers, that means m favorable cases for the happening of any event. Suppose you are considering that one as E. Then the probability of happening of this event is denoted by probability of E, and this is given by the number of favorable cases by the number of all possible events. So here we are consider this n as the number of all possible events, and m is nothing but the favorable cases for the event E, for the event this one E. So obviously, so if there are m favorable cases out of n, then this n minus 1 will be the non-favorable cases, correct? So the probability for non-happening of the event E is generally denoted by Q, and if E is occurrence of any event E, then E complement will be non-happening of that event, and the probability of this E complement is generally denoted by Q. Okay, and this is given by Q will be total number of all possible cases, and here the number of non-happening cases will be n minus of m. Okay, so from these two relation we can actually calculate the probability value, total probability value, and this can be easily find out by using um, this one. So P plus Q, which one will be 1. So where actually this one is come from? So if we split this one, so if we divide it by n, so then we can get this one. So that means, and 1 minus this one is nothing but P. So this can be written as actually P. So 1 minus P equal to Q equal to 1 minus P, Q equal to 1 minus P, and from this relation we can get P plus Q equal to 1. Alright. Okay. So next, uh, we can actually find out the range of a classical probability. That means what will be the range in our P and Q. So what will be the maximum values for P as well as the minimum value for P. Okay. So as we consider n is the number of all possible events, suppose we are considering the maximum to maximum number is n. That means that if we consider n is total number of possible events, similarly also the number of favorable cases are n. That means the maximum value of p will be 1, as well as if we consider total there are n different uh, events, that means all possible events, and so there will be suppose no favorable cases. Okay, then that probability will be 0, and therefore the minimum value for p will be 0 and the maximum value will be 1. That is why the probability value is always lies between 0 to 1. So if we write probability, suppose any event E is equal to 1, that means that one is called a certain event, and probability of E, which one is equal to 0, so this will be called an impossible event. So in our next lecture, so we will continue with the definition of statistical or empirical probability with axiomatic probability. Thank you.